In the quiet woods of Princeton, New Jersey, there is a place where the ordinary rules of the world seem suspended. The Institute for Advanced Study is a kind of sanctuary for thought, a cloistered campus where Albert Einstein spent his final decades walking the same stone paths. Today, another figure moves through this landscape, a man who, in the eyes of his peers, inherited Einstein's mantle. He is tall, with hazy eyes and an air of being only 1/4 tuned in to reality, as if the rest of his attention is occupied by more abstract thoughts. His name is Edward Witten. Among the assembly of geniuses at the Institute, Witten stands apart. Colleagues speak of him in tones usually reserved for mystics or prophets. He is called a high priest of theoretical physics, a genius's genius. His work is described as both powerful and feared, earning him the nickname the Darth Vader of physics. At physics conferences, he is the showstopper. He has an aura about him, and the world stops when he enters the room, says one of his students. When online physics forums debate on who is the smartest physicist in the world today, the name that comes up most often is Witten's. By some measures, he is the most influential physicist of his generation. His H-index, a metric of scholarly impact, is an astonishing 226, with over 270,000 citations, placing him among the most referenced scientists in history. In 1990, Edward Witten became the only physicist ever to be awarded the Fields Medal, the highest honor in the world of mathematics. This singular achievement gives a glimpse of his genius, a unique combination of mathematical power and physical intuition that allows him to see connections that elude others. He operates at the intersection of two worlds, using insights from physics to produce deep mathematical theorems, and then wielding those theorems to reshape physics itself. In a field like physics, which has traditionally built its authority on the hard ground of experimental proof, Witten's preeminence is a curious phenomenon. His most famous contribution is M-theory, a candidate for a final theory of everything that describes the universe as a symphony of vibrating strings and membranes in 11 dimensions. But M-theory, for all its mathematical beauty, remains a conjecture. Its predictions concern energy scales so extreme that they are a quadrillion times beyond the reach of our most powerful particle accelerators. There is no experiment that can confirm it. In the absence of empirical data, the field of fundamental physics must rely on other criteria to navigate its frontiers. It turns to mathematical consistency, to elegance, and to the sheer intellectual force of its leaders. Witten's authority is, in a sense, a substitute for experimental proof. He is not just a leading scientist. He is an oracle on Einstein Drive, a mind so powerful that his intuition alone can steer the direction of an entire field for decades. How did a man who started his career as a history major arrive at this position? What is the nature of the reality he describes? And what does it mean for the future of science when its deepest questions can only be explored in the mind of a man like Edward Witten? Let's find out. Edward Witten was born in Baltimore in 1951 into a world already steeped in physics. His father, Lewis Witten, was a respected theoretical physicist who specialized in gravitation and Einstein's theory of general relativity. The abstract language of space-time and cosmic forces was part of the household atmosphere. From a young age, Edward was captivated by the universe, not through equations, but through the stars. "I had a passion for astronomy," he recalled. "Those were the days of the space race." He dreamed of being an astronomer, though he also worried that by the time he grew up, astronomers would have to live and work in space, which sounded dangerous to him. His father gave him a small telescope, and one of the highlights of his youth was seeing the rings of Saturn for the first time. At age 11, his father introduced him to calculus, and for a while, mathematics became his new passion. The aptitude was clearly there, yet as he grew, he turned away from the scientific path that seemed laid out for him. His life, as he later described it, took some zigzags. He enrolled at Brandeis University and in 1971 graduated with a Bachelor of Arts majoring in history with a minor in linguistics. He had aspirations for journalism and politics, publishing articles in the New Republic and The Nation. For 6 months in 1972, he worked on George McGovern's ill-fated presidential campaign. When McGovern lost, Witten tried a semester of graduate school in economics at the University of Wisconsin before dropping out. In 1973, at the age of 22, Witten abruptly changed course and enrolled in the Applied Mathematics program at Princeton University. The transition was shockingly swift. One of his professors tried to politely dismiss the former history major, suggesting he read a notoriously difficult graduate-level textbook on electromagnetism. Witten returned 2 weeks later. "I have read it and I understand it," he reportedly said. "What's next?" The professor, skeptical, began asking questions and found, to his astonishment, that Witten had indeed mastered the material in a fraction of the time it would take a typical physics graduate student. Another lecturer from his early days at Princeton recalled that Witten's questions in the lab went from basic to brilliant to Nobel level in just 3 weeks. He had found his language. He quickly switched from applied mathematics to the physics department, where he began working with David Gross, a brilliant physicist who would later win the Nobel Prize for his work on the strong nuclear force. Witten received his PhD in 1976 after completing his studies in just 3 years. His ascent was immediate. He became a postdoctoral fellow at Harvard, was awarded a MacArthur Genius Grant in 1982, and by 1980, at the age of 29, was a full professor of physics at Princeton. The zigzags were over. He had found the field that was vast enough to contain his intellect. Witten's work is often described as a bridge between the worlds of physics and mathematics. He has a unique ability to see deep, hidden connections between the physical laws that govern the universe and the abstract structures that mathematicians explore. One of the first demonstrations of his intellectual prowess came in 1981 with his work on a nagging problem at the heart of Einstein's theory of general relativity. The theory describes gravity as the curvature of space-time. According to Einstein's famous equation, E equals mc squared, matter and energy are equivalent, and they are always positive quantities. But the energy of a gravitational field itself is negative. It is a binding force that pulls things together. This created a disturbing possibility. Could a system of matter collapse so violently under its own gravity that its total energy becomes negative? If so, the universe would be fundamentally unstable, capable of spontaneously creating matter and antimatter from nothing without violating the conservation of energy. Mathematicians had managed to prove this theorem before Witten, but their proofs were notoriously long and complicated. Witten produced a new proof that, by contrast, was stunningly simple and elegant. He achieved this by importing a tool from a completely different area of physics called supersymmetry, a theory that proposes a deep symmetry between the particles that make up matter and the particles that carry forces. He was able to show in just a few pages that the total energy of a gravitational system must be non-negative, using concepts from supersymmetry. It is considered a masterpiece. Witten's most celebrated contribution to mathematics came in the late 1980s, when he turned his attention to a field that seemed as far from physics as one could imagine: the theory of knots. A knot, to a mathematician, is simply a closed loop of string in three-dimensional space. The central problem of knot theory is to determine, without untying it, whether a complex tangle is truly a knot or just a complicated loop that can be undone. In 1984, the mathematician Vaughan Jones made a discovery that electrified the field. He found a new method, called the Jones polynomial, to assign a unique mathematical expression, a sort of fingerprint, to any knot. If two knots had different Jones polynomials, they were definitively different knots. It was a powerful new tool, but it was essentially a brilliant mathematical trick. No one knew what it meant or where it came from in the physical world. Witten revealed the answer. He demonstrated that the Jones polynomial naturally emerged from the physics of a topological quantum field theory, a specialized type of quantum theory where physical quantities depend only on the topology, its fundamental shape, of space-time, rather than its geometry. Specifically, he demonstrated that the Jones polynomial could be calculated using a framework known as Chern-Simon's theory in a simplified universe, with 2 dimensions of space and 1 of time. The discovery was a revelation. This unexpected connection between pure mathematics and fundamental physics was so extraordinary that in 1990, the International Mathematical Union awarded Witten the Fields Medal. He was a physicist, but he had given mathematicians a new way to understand their own world. By the mid-1990s, string theory, the leading candidate for a unified theory of physics, was in a state of crisis. The theory proposes that the fundamental constituents of nature are not point-like particles, but tiny one-dimensional vibrating strings. Different vibrations of the string correspond to different particles, just as different vibrations of a violin string produce different musical notes. The theory was beautiful, and it naturally included gravity, something no previous quantum theory had managed to do. But there was a problem. There were 5 different, consistent versions of string theory. Did our universe correspond to one of them? And if so, as one physicist joked, who lives in the other 4 worlds? The answer came in a legendary lecture Witten delivered at a string theory conference at the University of Southern California in 1995. He proposed that the 5 string theories were not rivals at all. Instead, they were 5 different approximations of a single, more fundamental theory that existed in 11 dimensions. He called this underlying framework M theory, leaving the meaning of M tantalizingly ambiguous. It could stand for magic, mystery, or membrane, depending on one's taste. His talk unified the field. It launched what became known as the Second Superstring Revolution, a period of intense activity as physicists rushed to explore the consequences of his idea. M theory remains the leading candidate for a theory of everything, a single mathematical structure that could, in principle, describe all the forces and particles of nature. For all his achievements, there is one major scientific honor that has eluded Edward Witten: the Nobel Prize. The reason is simple and goes to the heart of the current state of theoretical physics. The Nobel Committee has a strong preference for theories that have been confirmed by experiment. Witten's work, particularly M theory, operates in a realm far beyond our current experimental reach. The strings and extra dimensions it posits are thought to exist at a scale millions of billions of times smaller than what can be probed at the Large Hadron Collider. Some have argued that his ideas are a century or more ahead of their time, a theoretical structure waiting for technology to catch up. This disconnect from experiment has led some to criticize string theory as being more like theology than science. But Witten operates with a different kind of faith. He has been described as a naive realist, a person who believes that the elegant mathematical equations he uncovers are not human inventions, but discoveries of a truth that exists independently of the human mind. For him, the internal consistency and beauty of a theory are powerful forms of evidence. He once called the fact that gravity is a necessary consequence of string theory one of the greatest theoretical insights ever, even though it was a post-prediction, a fact that was known long before the theory was developed to explain it. In a sense, Witten's journey has been a continuous act of unification. His proof of the positive energy theorem connected general relativity with supersymmetry. His work on knots connected quantum physics with pure mathematics. M-theory connected 5 disparate string theories into one. In recent years, his focus has shifted. The grand, unified picture of M-theory remains, in his own words, still very hazy. The search for a single, final theory of everything has given way to a more subtle exploration of the landscape of theories. Much of his recent work investigates the complex network of dualities, surprising equivalences between different physical descriptions. His papers now delve into the entanglement properties of quantum field theory, the nature of observables in an expanding universe like our own, and the deep connections between high-energy physics and the behavior of condensed matter. He seems at peace with the idea that the final answers may not be simple, having made his peace with the realization that the universe hadn't been created for our convenience. For a man who inhabits such abstract realms, Edward Witten is described by those who know him as remarkably grounded and approachable. He is modest and unassuming, known to answer emails from strangers and to be generous with his time with students. He speaks in a soft, high-pitched voice with a precision that suggests a mind that thinks far faster than it speaks. His favorite pastime is tennis. People have at times played tennis with him for more than a year without ever realizing he is one of the world's most famous physicists. Science is a family affair. Witten met his wife, Chiara Nappi, a professor of physics at Princeton University, at a physics summer school in the French Alps in 1975. They married in 1979. Their children have followed similar paths into science. Their daughter Ilana is a neuroscientist at Princeton, and their daughter Daniela is a biostatistician at the University of Washington. His wife has observed that he rarely performs calculations on paper, preferring to work through complex equations in his head, sometimes while staring out a window. This intense internal focus contributes to legendary productivity. One colleague estimated he produces enough material for a PhD thesis every month. Beyond his family and his work, Witten has maintained a quiet but consistent engagement with the world. After his early foray into political journalism and a 6-month stint on George McGovern's 1972 presidential campaign, he has focused his efforts on a cause of personal importance. Since 1992, he has served on the board of directors for Americans for Peace Now, an organization advocating for a 2-state solution to the Israeli-Palestinian conflict. He once summarized his life's devotions, saying that apart from his family, he has three passions: physics, tennis, and Israel. He is humble about his own creations, admitting that M-theory is still very hazy, and in a striking admission for a physicist, he believes that consciousness will likely remain a mystery, a phenomenon he is skeptical will ever be fully incorporated into the laws of physics. It is a view that encapsulates the man, a mind that has pushed the boundaries of human knowledge, yet remains acutely aware of the vast, undiscovered country that still lies beyond.